When you hear the word nuclear, what do you think of? Many would think of tragic events involving nuclear energy, such as Chernobyl or 3 Mile Island. Some may even think of the controversial use of nuclear weapons. However, nuclear energy provides many benefits to the energy supply worldwide. Other than a clean energy source, nuclear energy is highly sustainable and plentiful. In this video, we will discuss these benefits provided by nuclear energy. In order to remove fear and extend the beneficial applications of this form of energy, the concepts must be understood by students and scientists alike through educational media supported by state-run universities or government bodies.
Listen up, Safe. I will spill your contents even if I have to tear you apart. Yeah. Bit by bit. Yeah. Molecule by molecule. Atom by atom. Uh-oh.
So you ask, where does nuclear power come from? This is a nuclear power plant. The main parts are the cooling tower, containment vessel, water tank, turbine, and generator. When a nuclear reaction takes place, massive amounts of energy are released into the environment. A nuclear reactor contains that energy and uses it to heat up water. The heated water turns to steam and spins a turbine. That turbine powers a generator, which produces electricity. So now that you know how a nuclear power plant produces electricity, let's see how a nuclear reaction takes place. Let's zoom into the atomic level. The two types of atoms used are uranium-235 and plutonium-239. The nuclei of atoms consist of protons and neutrons, which is surrounded by an electron cloud. In an atomic reaction, a lone neutron is shot at the nucleus of the fuel atom, which splits the atom into smaller particles and more lone neutrons. Those lone neutrons hit other fuel atoms, causing a chain reaction. This releases enormous amounts of energy. The University of Wisconsin-Madison participates in nuclear energy research through a nuclear reactor lab. One of the undergraduate students participating in this research shared his expertise and opinions on the topic of nuclear energy and its sustainable characteristics.
Educational and experimental purposes. The reactor is used to train people in reactor physics and how to just simply run the reactor. There are different systems for experimentation, such as one where you can put small samples into a plastic dauber and expose them to radiation in the core. They're called whale tubes. These tubes go all the way down to the core, and they have jets at the bottom that basically create a pressure differential to suck the tubes down. And they move towards the core and they kind of sit down there and just get irradiated. The bulk of what we do are things like that, just training and experimental radiation sciences. Because we have a training reactor that's so small and can run at 1 megawatt 2 days a week at full power, which is required, we have to do that. And that fuel lasts years. I mean, normal nuclear reactors are much larger than ours, but just it gives scale. Just to know how long this fuel in our small little reactor works and how high of power we go to. So, I mean, and you know, uranium is extremely easy to come by. It's very cheap. And it's just mind-boggling that many little pockets of fuel, with really small little fuel rods that we have, can last years and years for what we do to them. I guess this reactor just proves that nuclear fuel does its job and lasts a long time. There's 4 student operators, 2 immediate faculty members I can think of, and many other students who use the radiation facilities for research, experimentation, and other classes that they have to do with radiation. It's a good baseline energy source. So like with cities, you'll have an average baseline amount that the city needs, which throughout the year is about the same. It'll fluctuate obviously, but you always need around the same amount of energy. So nuclear energy is a very consistent energy source, so the power output will also be very consistent for months, long periods of time without having to refuel. So you've got a reliable energy source, so you can compare this to other energy sources like oil, where if there's a shortage, the price might skyrocket, or this might somehow affect power output. But this nuclear power can be paired with renewable types of energy, which can make up the difference in the fluctuations, because nuclear power isn't you can't change it fast. It's very good at sitting at a base power level. That's why it's good for a baseline power level for cities or high energy consumption areas. First, I just want to make it clear that the UW nuclear reactor doesn't actually produce any power, as you might believe. It simply disperses its heat into the pool that's in. So really when I say power, when referring to our reactor, we go based off of more or less power approximations due to the nuclear instrumentation, which takes into account neutron counts and other sources of radiation such as gamma. So this is all just for research and radiation experiments is really what I'm trying to get at. So our reactor specifically works by taking fissile uranium-235, which is in the fuel, and splitting it due to neutrons hitting those atoms. So the splitting of the atoms causes more neutrons to come out than what was used. So this is almost always one. One neutron hits the uranium-235 and then it is absorbed and the uranium splits. And the splitting of the atom, like I said, produces more than what was needed. So that's like on the range of 2.4. The average is somewhere around there. So it has a net positive, which allows it to cascade and to continue the reaction. If it didn't, that'd be a little bit of a problem. This produces heat, fission products, and radiation. So the heat is usually what's used for, which is what's always used for power production in a regular reactor. It'll heat water, it'll turn to steam and turn a turbine. Like I said, ours doesn't do that. So fission products are the spent fuel that you hear a lot of negative feedback about. So like I said, you got heat, fission products, and radiation. So the fission products are the bad things. Those can decay over time and produce more radiation. And so just like a commercial reactor, everything that happens in the fuel stays in the fuel. So those fission products don't leak into the water or anything like that. It all stays in the fuel. So when you try to replace it, it's all just in there, and you don't have to worry about it going anywhere. So it's contained, more or less. We control the neutrons in the reactor, in the core, that causes the reactions with control blades that absorb the neutrons. They are strategically placed in the core to capture as many neutrons as possible so that no reactions can occur when they're completely in. We pull the blades to reach different power levels. So we cool it with water. It's very important to cool it because if you don't cool it, a meltdown can happen when the cylinders break down and the fuel is allowed to spread and do its thing. So we cool it with water, and we also ventilate the building so air goes out the top of the building and can be dispersed so that any radiation particles that were in the air from the reactor are released and basically diluted in the air. And that's another amazing thing about radiation and stuff. It's very easy to contain when you don't have large amounts of it. You can just dilute it, and it's really not that big of a deal. So, and that's the same with irradiated water. So, with the water that we use to cool the reactor, we have to keep circulating it through, and eventually, we want to get rid of it because there's too much crap in it. And so what we do is we put it into a holding cell, and this also is connected to the labs and stuff. So if there's ever like a leak somewhere, it all drains into this holding container under the reactor. And we eventually have to get rid of this water. And what we do is we dilute it and we release it to the sewage, the sewage system of Madison. So, and what's pretty incredible about this is that if anyone were to drink this water, just straight up drink that water that's coming out from the sewage system, if they drank it for a full year, all that, what you would believe is nasty irradiated water, you actually wouldn't be affected by it. So the biggest problem with nuclear power isn't, I guess, the power source itself, or nor really the industry, because the regulations are there. It's just very small little nitpicky things that happen, and the public kind of overreacting about them. And that's been happening for years and years now. But a lot of these situations weren't really even that bad. 3 disasters over the last 70 years doesn't seem like a bad track record to me compared to other industries. I would just say check the UWNR website. There's some information on the reactor there. They also have the faculty on there, so if you'd like to contact them about questions you may have, I'm sure they would love to talk about that. Go to a ANS meeting. Talk about nuclear power or anything like that.